Starting here in just a minute. Welcome to Friday. If you're watching this live, I have not looked at the test yet. This was recorded on time on Friday during class. Friday is the last day of the quarter, so for those of you that do not get this done, you actually have it until Friday midnight to get it done. If you haven't taken the test by Friday midnight, it's a 0. Make sure you get it done. All right, we haven't done an algebra review in a while. So remember our book, we'll throw in these algebra reviews when the technique or the skill, the algebra skill that we do a review on is used in the very next chapter or very next section. So there's nothing, this isn't a really complicated one. This is a pretty easy one. I'm going to switch to the presentation here. Pretty quickly done. It's not going to take me the full class to do this. So here we go. So algebra review number 10. We don't have school on Monday, so we'll start chapter 11. There's only 3 chapters left. So we got 3 chapters, and we're done with the book. So we'll definitely finish the book. And then chapter 11 is split between spring break. So clearly we'll probably have to do a review day when we get back from spring break, just to remember what the heck it is we did for 11.1 through 11.4. Haven't made a decision on the quiz. I'm not going to give you a quiz before spring break, so don't worry about that. Since it's that break there, I may or may not give you a quiz in chapter 11. We'll see how it goes. All right, here we go. Homework I'll show you at the end of class, so you got to listen to the whole darn thing, end of class. Talking to Mr. Surratt in this class I'm about to show you, he uses this all the time. So this is one of those skills, one of those algebra skills that's very applicable to science. It's a requirement. Scientists don't even give this a second thought. They just kind of do this. As mathematicians, there are occasions when this makes a lot of sense to do this, but we certainly don't use it as much as the scientists do in science class. All right, so easy review for a change. We're not reviewing quadratics or anything like that. Here we go. You guys have heard me use the term plug and chug before if you have me for algebra class. Plug and chug is this idea is I throw you a formula and you plug in some numbers and then you chug through the calculation. So this is our plug and chug class. Please write this one down. So evaluating, it's one of the 4 big ones that we do in math. Let's see, we simplify, we factor, we solve. We also do this thing called evaluate. Evaluate is the process of I hand you a formula of some sort or an expression, either one, and you replace the variables with some given numbers, and then you simplify. Remember, simplify, big fancy math word for do the math. All right, follow PEMDAS. So evaluating, I'm going to give you a formula. You're going to plug in some numbers, and you're going to chug through the calculation. We'll do some more today as well, too, but that's the idea of evaluating. And I'll pause for you to copy this down. We have anybody live? Oh, it's just me all by myself talking to a computer screen. How wonderful. All right. For those of you watching the video, I highly encourage you next week to watch the classes live so you can ask questions. So I will teach this during the normal times. If you forget when the times are, look at any one of the old assignments, and I always have the link to the class and the time that it appears. Friday is the only weird time. So Friday, remember, we start at 9:17 rather than normal time. All right, back to class, evaluating. Here's an example of evaluating. I have an expression here, not a formula. So here's an expression, no equal sign. It says 2x plus 3y. To evaluate this, I have to tell you what I want x and y to be. So you'll see a statement, something like let x be 4, let y be 5, and then figure this out. So it's not a complicated process. All we do is plug in the values. That's the substitution. I let x be the value 4, y be the value 5. I highly encourage you to put parentheses. That way it doesn't look like 24 plus 35, especially if there's negative numbers involved. You know, you won't confuse it with subtraction. And then we do the math. The simplify part of this is simply follow PEMDAS. PEMDAS says we need to do multiplication first. 2 times 4 is 8. 3 times 5 is 15. Notice I say GEMDAS here because G stands for grouping symbols. There's other grouping symbols besides parentheses. So that's 8 plus 15, which is 23, and you're done. Yes, I did say today would be an easy class. All right, I'm not going to have you do any practice. Those are way too easy. So let's talk about formulas. Well, formula, well, it kind of looks like an expression, except it will have an equal sign. All right, a formula is an equation that states a rule about a relationship. So for instance, I don't know, force equals mass times acceleration. You did that in science class. That is an equation that states the rule. What's the relationship between mass and acceleration and force? So here's an example of a, I'll give you a pause to write that down, formula. Here's an example of a math formula. Force equals mass times acceleration is a science one, but here's one. Got a parallelogram right here, and the perimeter of a parallelogram would be to take x and double it, and take y and double it, and then add them together. Remember, parallelograms, opposite sides are congruent. So if one side is x, then the other side, opposite side is x. If one side is y, then the opposite side. So perimeter, we define that as the distance around an object. So this would be 2x plus 2y. So P for perimeter, remember it said formulas are equations. So P for perimeter is equal to 2x plus 3y. And by the way, all I did was take that previous expression, 2x plus 3y, put an equal sign and a P on it. And now I turn it into a formula. So there is a relationship between an expression and a formula. Okay. To evaluate this, then obviously we'd have to know the distance of x and y. Today, we're going to be evaluating both formulas and expressions. So it's simply a plug and chug class. So let's do some. All right, some of these will not be nice. Some of these will be nice. So here's an example of one that I wouldn't show this to an Algebra 1 student, but to a geometry student who's familiar with square roots and doing math with them, it's not that big of a deal. Anybody recognize that formula? I know I'm talking to myself still. Anybody recognize that formula, 1/2 base times height? Yeah, that's the formula for area of a triangle. We will see this chapter, by the way, 1/2 base times height. Chapter 11 is the chapter that you thought that geometry was when you walked into class. Hey, isn't it shapes and area and volume? Yep, that's chapter 11. So 1/2 base times height. By the way, I haven't proven that to you, so we don't yet know for sure that 1/2 base times height is the area of a triangle, but we will prove that this chapter. All right, it says to evaluate for the given values. We're told that B is 12 and H is, oh, how come they couldn't say 6? No, they make our lives more challenging and say 6√3. Don't panic. You've done this math before this year. So I plug in the values. Well, 1/2 is still 1/2. B is now 12, and H is 6√3. All right, here's how I would handle. There's lots of different ways to handle it. Some people would immediately divide 12 by 2. You could. Other people would multiply straight across. All right, that's one technique. 1 times 12 times 6 times √3. 1 times 12 is 12. 6 times 12 is 72. So I get 72√3 over 2. Now, some might argue I would rather do 12 divided by 2 is 6, and 6 times 6 is 36. Okay, we can make arguments for that. I'm showing you one technique. I'm multiplying all the tops. Remember, since we're multiplying with fractions here, that this is a fraction and this whole thing is still a fraction. 2 times 1 is 2. And 1 times 12 times 6 is 72. And we can't multiply √3 because there's no other square root symbol there. All right, well, we can reduce this one. Notice this would reduce 72 divided by 2 is 36. So 36√3 is your answer. Like I said, other people would say 12 divided by 2 is 6. 6 times 6 is 36. It's still the same number of steps. Questions on that one? Okay. As I said, some of these, it's geometry, so some of these are going to be friendlier than others, and some of them are going to be complicated. Look at this one. All right. There are two problems here. There's a problem here. Let me draw a line here. There's a problem here on the left, and there's a problem here on the right. So one at a time. All right, the one on the left. So it says x minus 3 over 2y plus x when x is -2 and y is 6. Remember, we're going to plug things in, use parentheses so you don't confuse yourself. All I did was replace x with -2 and y with +6, and then we do PEMDAS. -2 minus 3 would be -5. 2 times 6 is 12. 12 plus a -2 would be +10. Well, that clearly reduces to -0.5. I'll pause there. Make sure you see what the math I did there. All I'm doing is replacing values and then just using PEMDAS, GEMDAS to do the rest of the math. All right, the more complicated one here on the right, it's only more complicated, so we got some square roots floating around here. It says a times the quantity a plus b. It says a is 2 root 3 and b is 4 root 3. So all I'm going to do is replace those. So I'm going to replace a with 2 root 3. I'm going to replace b with 4 root 3. Notice there's a big honking mess here. As it appears right here, we need to use the... Yeah, I'm going to stop asking questions because there's nobody live here. The question is, what do we do here? Well, it's distributive property. You see the two parentheses right here? So it's a distributive property. Let's see. 2 times 2 is 4. Root 3 times root 3 is 9. And the square root of 9 is 3. Now, if I write this without, that's the first arrow. And then your second arrow would be 2 root 3 times 4 root 3, which will give you 2 times 2 is 8. Root 3 times root 3 is the square root of 9, right? Some people would immediately, I'm going to show you the math here. The first arrow will be the square root of 2 times root 3 times 2 times root 3. 2 times, oh, I see what I did here. The first way, I'm going to go back here and show you 2 different ways of doing this one. All right, so the first way is what I said was the distributive method. That would give me 4 times the square root of 9. That's the first arrow. Where did I get 9 from? 3 times 3 is 9. And then plus, second arrow would give me 8 root 9. And notice, square root of 9, square root of 9, we can add those together and we would get 12 root 9. And the square root of 9 is 3. So we would get 12 times 3, and that is 36. I forgot I simplified this. Now, the second way of doing that would be, well, notice, let me do this in blue here. Notice on the inside, we have 2 root 3 plus 4 root 3. Remember, you can add them as long as the square roots are exactly the same. I can't add the square root of 3 plus the square root of 4, but since they both say the square root of 3, I can add those together. So we would wind up with the previous thing I just showed you, 2 root 3 times on the inside, we would get what? 6 root 3. Remember, you can only do this because the square root symbols are the same. Now we can multiply those together. We better get 36 as our answer. Let's see. 2 times 6 is 12. And the square root of 3 times the square root of 3 is the square root of 9. And notice the square root of 9 is 3. And we do, in fact, get exactly the same answer, which is 36. All right. I'm going to pause there, have you take a look at that. Yeah, you don't have to do it both ways, by the way. Either way is fine. Okay. And nice and pretty using my method, the second method right there. We still get 36. All right. Let's see another one. Well, some of you would argue that the previous ones weren't nice and pretty answers either. All right. So let's see some of the more challenging ones. All right, maybe you remember this formula, B is equal to 1/2 R times S. Maybe you've never seen that before in your life. It's fine. We'll explain what that formula is later in the chapter. If you remember what it is, great. But if you don't, it's not important to do this one. So it says, use the information to rewrite the expression. It says BH when B is equal to 1/2 RS. So this one's harder to understand what the heck's going on. So here's what it means. What it means is, here is the expression B, capital B times H. And what it wants you to do is replace the capital letter B with 1/2 RS. So that's what it's asking you to do. It's asking you to replace the capital letter B with 1/2 RS. Well, that sounds complicated, but literally just replace B with that. So if I replace B, well, the values I'm going to plug in is 1/2 RS for the capital letter B, and then attach an H to it. And you're like, well, where are the numbers? Well, this one is just moving things around with variables. There's actually no numbers that I'm throwing in here. I'm just replacing variables with another variable expression. So actually, that's the whole answer right there. That wasn't too bad. Now, occasionally, notice there's a second step here. I put this in because the very next example has another step. Your last step would be to look at this expression and see if there's any more math that you can do on the inside. Well, there's nothing I can do. And you're like, well, why? When would there be something else I could do? When would this be this other step right here? Well, the next example will show that. So I'm just going to pause here. Notice that these two right here are exactly the same thing because there was nothing that we could do in this last step right here. Right? There was no math that we could do to this. Okay, there will be on the next one. All right, let's see what that would look like. One where there's that extra step there. All right, so once again, here are two more examples. We'll be able to do some stuff here in a second. I'll draw a line down the middle. So this one right here. So it looks like the previous one, except there's got an extra 2 written right here. So it says here is the formula, A times the quantity A plus B times 2. When AB, I should probably do that in red, when AB, or A plus B, not AB, is equal to X. In other words, it's saying if you see A plus B, you can replace that with an X. Do I see an A plus B? I sure do. So I can replace that right there, A plus B, with the value X. See how complicated this can be at times, right? So all I do is replace A plus B with an X. Any more math we can do? Well, we like it when the 2 is out front. So there's not much math going on here other than changing the order of the numbers. We like our coefficients to be out front, so 2ax. If you wrote ax2, would that be the same answer? And it would be, and I wouldn't mark it wrong. All right, I promised you one where would be a little bit of math to do. There's a little bit of math. How about one with a bit more math? So on the second example right here, here's the formula. And it says, if I see N and an S next to each other, I'm gonna replace it with a P. Well, I don't see an N and an S next to each other. However, remember, multiplication is commutative. We got a whole bunch of things being multiplied together. I could rearrange that just using standard multiplication. I could rearrange it, just rearrange the order of multiplication. Instead of 1/2 times S times A times N, put the half out front, kind of like what I did on this first one, and then write NSA. Now I have an N and an S next to each other. Now I can replace that NS. I can replace that NS if I see an NS with the letter P, and I just did that. Okay. So there is your example of when you can actually do some math. All right, neither one of these is an algebra 1. These are geometry type manipulations, but you can also see this in science class as well too. You should not recognize the second formula or even the first formula. These are two formulas that we will encounter in this chapter, both of these right here, 2ax and 1/2 PA. And if you had me for pre-algebra, did you guys have me? Yeah, you did. You had me for pre-algebra. This is a formula I talked about way back in 8th grade. And I said, wait till high school, I'll teach it to you. All right. Oh, let me clear that. Said if you were actually here in class, there's no one here in class right now, I would have said, open up your books to your homework and pick one, and we would do one together. Since no one is here in class, here is your homework. If you would like, pick one over this weekend when you're doing your homework. Pick one, send me a chat, and I will help you work through it. If not, then just try your homework all by yourself. I'm assuming that some people didn't show up to class day simply because it's a Friday and you forgot that we're on a different schedule. But please show up on Monday so it's just not me, or Tuesday so it's just not me talking to yourself. Otherwise, it's going to be a long, long week, and I'm probably going to talk way faster than I need to. All right, yes, I'm lonely. Okay, guys, have a great weekend. I know I will. We actually, teachers have to work on Monday, but you guys don't. So enjoy your 3-day weekend. We'll come back. We'll knock out four days, do some solid work for 4 days, and then we'll go on spring break. All right, I'll stop it right there. And once again, have a good weekend. See you guys Tuesday.